ever faced a mystical bug so hard to fix you believe your code was haunted by a ghost, possessed by a malicious spirit, at the point you tried to exorcise your computer? But it did not work. Hello everyone, my name is Remy and here is Yann.
Hi everyone.
We are both software engineers at Poirot for respectively 7 and 9 years. We're consultants and have developed different kinds of web apps during these years: news site, marketplace, complicated software for insurance and banks, etc. And spoiler alert, we've seen some bugs. So, let's say altogether we're coding and boom, a wild bug appears. We might have some reflexes, but could we explain formally what we are gonna do? Developers spend basically half of the time debugging. A failing test, a broken build, or service downtime, whatever happens, we have to understand what is happening and repair it. Unfortunately, we learned a lot about coding and building, but have we ever had a debugging course or read a book about it? Maybe not. So with Yann, we'd like to share you our approach to this practice, which is debugging. Okay, first of all, you're facing a bug. But before fighting the bug, fight against the stress. Accept that stuff breaks sometimes. Let's leave our keyboard for a while, drink a glass of water, do whatever we need to keep a cool head. Well, seriously, do not panic. I insist. Stress leads to mistakes, which leads to more bugs, which induces more stress. It's an infinite vicious loop. Even if our production is burning, let's not touch the keyboard before feeling relaxed. Okay, now our brain is back in Zen mode. Let's take some time to verify the bug is actually a bug. By a bug, I mean an unwanted behavior. Our code base might have gone too fast, our product owner have forgotten some edge cases, and the strange behavior we are facing right now is a feature useful for our users. But let's assume this is not the case here to make the story a bit longer. Next step, before going any further to fake this nasty defect, look at it frankly by representing the dysfunction. Do it where it occurs to be 100% sure you are hunting the right problem. Avoid the classic, it works on my computer. Obviously, if making our system fail again harm it by removing production data, for example, please don't do it. The bug consequences are enough to believe there is an issue. If we struggle to replicate the failure, just add logs to monitor potential issues, but don't try to fix a bug that you can see. Anyway, software are mostly deterministic, so it is very likely we'll find a way to reproduce the error. After that, we are looking for a clue. And most of the time we can find one in the logs. The hard part here is to find the logs. Our brother console, our terminal, maybe in Kibana, or worse, somewhere in the var log folder of the production server. In this case, please ask help from an ops. If you don't know where to seek, look at the documentation, ask for help. In absence of log, just wait for the step number 10. We are not ready yet. So, step number 6. We've found an error message. Great. Now, let's read it completely. Like plain text. Read it from left to right, from top to bottom, if it's English, of course. I'm just serious. The most common mistake I see from developers struggling to find bug root cause is jumping to conclusion at their first guess. But the answer lies just under our eyes. It's written red on black. But to see the answer, we have to read the error log again. It's hard to interpret a stack trace at first sight. The first time we decipher the stack trace, the second time we understand it. And after understanding the stack trace, it's done. It just was a typo and the bug is solved and the talk is finished. Of course not. Obviously, it's not always as trivial as this. But there are usual suspects. Typo is a good one. There are also forgetting to import a package, forgetting to npm install after a git pull. It happens to me every time. Using a cached bundle with a new version of our backend. Well, look at the last thing we changed before the failure happened. What library have we installed? What change have we made in our configuration? If the error message is clear, we'll be able to connect its meaning with recent changes in our code base. But if the error message sounds like gibberish, search for it online. But a little tip, copy it entirely, because it's what people do when posting on Stack Overflow or GitHub, they write the error message entirely. Maybe we're lucky and the project with me has a troubleshooting too. troubleshooting section, sorry. And maybe this troubleshooting section explain what the error, gibberish error is. If we can't find anything, we are facing a hard bug. So, roll up our sleeves, and let Yann explain the next steps.
Okay, we have eliminated the obvious causes, and the bug is not fixed yet. Before gearing up, we need to be in the correct mindset. What does that mean? Sometimes we see things that we don't understand, and our first reaction can be to dismiss it as it can't happen. But it has. So we should open our mind, stop twisting facts to suit theories instead of twisting theories to suit facts, to quote Sherlock Holmes. Okay, now our mind is ready. It's time for us to gear up to prepare for the debugging session awaiting us in 4 phases. The first one is to, before diving in, it's important to warn our team about what we are about to begin. It wasn't scheduled. They may have some insights concerning the bug, and we don't want someone else working on the bug without consultation with us. Here, for this second one, I'll make an analogy. In motorsport, when a vehicle has a problem, the mechanics try to fix it quickly in the pit lane before taking the car to the garage where they can use all their tools. Here, in software development, it's the same. We try to solve the bug quickly. Now we should spend time to reproduce the bug locally, where we can use our debuggers and developers tools. Now that we are able to reproduce a bug locally, the idea is to have the shortest, simplest, deterministic way to make the bug happen. Even better, we can automate it with a test. The process we follow later is iterative. The faster we can assess if the bug is still here, the better. Later, we'll also need to think a lot. It will be easier for us to guide and articulate our thought process if we use a place to write it down as a support. Are we prepared? Yes. Fully prepared? Not quite. We are going to navigate in the meanders of our app, and the best way to not get lost is to have access to a map. Have or make a diagram of how our system is supposed to work, from one end to another. Here we should see our front end, our back end, the server, the cache systems between them, the data stores, every cog that is a part of our machine. The goal here is to be exhaustive, to be sure the bug is somewhere on the map. If it looks like this, it is too detailed and it won't help us. If we don't know where it is or how to make it, stop right here. Knowing how our system works is mandatory for daily work. It's time to ask for help. In the end, it should look like something like this, or even this kind of diagram.
I have an example for this. On one of my projects, we had to send requests to our WebRTC server. Problem, the async call was failing erratically, and the log was not giving us any input to find the cause of that. So we had to reverse engineer our own code because it was full of legacy code. And there was a method on my library object that was not documented. Where this method does come from, if I was not aware of prototypal inheritance in JS, like in this example here, I would have never found where the code was really set up because it was set up like in the beginning of the app boot and lost somewhere in the code.
Okay, thanks to this map, we have a global vision of our system. It is now time for us to make an hypothesis about what is going wrong. Here, we will use our experience, our knowledge of the code base, the error message, if you have one, the way we reproduce a bug, our gut feeling to select the element most likely to be faulty. Different people will have different favorite suspects. That's not a problem. At worst, pick one randomly. But sometimes, even picking randomly feels off. The bug just seems weird. There are famous examples of bugs with crazy symptoms on the surface, like the 500-mile email or a bug only happening on Wednesdays. But we shouldn't get carried away by these weird facts. For instance, a bug only happening at a specific time period can be due to the background task or an increase in traffic. Now that we have a candidate, Let's assess it with an experiment to have a scientific approach. In this experiment, we will check the content of a variable, a property, a database entry, or edit something in the app, or input to highlight a new behavior. Before doing this, we will enunciate what should happen if our hypothesis is valid or not, and write it down in our notes to avoid self-persuasion. After the experiment, we'll use the dichotomy principle to progress. If our hypothesis is valid, then we can zoom in and continue at a smaller scale. If it is invalid, we have ruled out a suspect and we can choose another one. In both cases, we learn something. The experiment result doesn't really matter. The application we are working on is a finite system with a finite number of components, a finite number of lines of code, even with dependencies, a finite amount of bytes exchanged. By repeating experiments, we will zoom in and find a place where it went wrong. There are several ways to use dichotomy, and by being smart, we can reduce the number of steps needed to converge towards something. We can have a time-based approach. The bug wasn't there last week. Here it is now. It should have been introduced in the meantime. And with tools such as Git bisect, we can find them when and with which commit. Systemic approaches are also valid. If our code calls successively components A, B, C, and D, we can check if the input given to C seems correct. If it is correct, C or D should be faulty. Else, we need to look more closely A and B, and so on. Here is the time to use breakpoints, not in a step-by-step way, more in a divide-and-conquer one. There are other approaches available. For instance, on a project having a bug in an old CMS having loads of plugins, we converged by installing a pristine CMS and then adding plugins until we reproduce the bug.
But sometimes using dichotomy this way is not enough. We get lost in our code base. The code seems uncatchable. Don't worry, our system is still not haunted. You have to take new perspective to look at it. And the first one is to read the manual of the technology we are talking with. Even the small lines, read it with the same seriousness as an error message. We might discover a misconfiguration in the dependency, learn a lot about a library to a point where you can enunciate new hypotheses.
Personally, I learned it the hard way. On my current project, during the first weeks, as we added features, the Webpack build went slower and slower until it became a real nightmare. With dichotomy, we converged to a plugin which caused this problem. We did not understand why, though, and once we read this documentation, we saw the warning in this box, and it became really clear. The build was slow because we didn't use the plugin the right way. It was our fault all along.
And speaking about libraries, don't stop debugging at our dependencies edges. Go beyond the dependencies edges. Open source libraries are everywhere now, and great news, it's code. JavaScript or TypeScript. Anyway, we know the language. Be confident, we already know the syntax. Don't be scared, this is a code you write every day. Moreover, it's a great way to improve our coding skills. Have you ever read some React.js code? Because you should. You see some good patterns to borrow, like better way to architecture your code base. Anyway, in the debugging context, remember it's all about finding the failing code channel or the function returning the wrong output. And if it lies inside the library, it's not a problem, you can read it. And fortunately, the problem could be unobservable in the code. I don't know if you ever studied electronics and used an oscilloscope or a multimeter, but we have the same kind of principles and tools in IT. Like, if we have a networking issue, it's not in the code that we will see it. Observe packets with TCP dump or Wireshark. If the bug has snipped into the operating system, use strace to look at the system calls if you're using Linux, for example. Well, the idea here, use the right tool for the right cause. The debugger is not always the answer. If we are facing a concurrency issue, it's a different kettle of fish. first, if you don't know the fundamentals, it's going to be a hard time. What is the lock? How behaves the race condition or deadlock? Maybe it's the time to ask for help again or read a good article or good book on the subject. We might need to dig in what an event loop is for Node.js, for example. As well, it's also hard to find the right tool. The best advice I can give for now is to use an open tracing tool like Jaeger or Zipkin. With this, we will be able to trace our request in all our systems with a request ID on every node. Really useful in a microservice architecture. Okay, now let's say we dug to the bedrock and still can't find this bug. So who are you gonna call? No, not Ghostbusters. Still not haunted. Okay, let's call your sensei. It means master in Japanese. Our team leader, our engineering manager, a colleague who we feel can help, even our CTO. Thanks to the notes we have written while hunting our ghosts, it will be really easy to involve people and will prevent following a path we already worked on. And what if you're the CTO and Julia Evans does not pick up her phone? Well, go online, but not on the search engine this time. Write a GitHub issue or ask a question on Stack Overflow. In fact, 70% of Stack Overflow's questions have an upvoted answer. Maybe some contributors have the same problem as us and know the fix. We're not alone, guys. Okay, let's say we got a very good suspect and we think we have a fix. It's not the time to celebrate yet. Keep our science spirit. So let's, I think the step is missing here. Yes. Anyway, I continue. No problem. First of all, you have to make a cleaning session. You have to remove all the console logs, all the stuff that is not necessary to your fix, just to be sure to keep the code that fix your bug. Then execute our test from step number 10. Yes, we developers are lazy, so we reuse the code. And oopsie, your test failed, but you had your fix. Admit it. We had an hardcore cleaning session and broke something by removing stuff that was necessary. So we have to find what we removed, and we have to debug our own fix the same way we debug bug. Or maybe our test is passing, and hooray, maybe we have a fix. But wait a minute. What if it's thanks to a side effect? It's not the time to celebrate it again. What we have to do to be sure that our fix is already a good fix is to check if the app breaks without the fix. So remove the fix. Just use git stash maybe, or revert to a previous commit, and reuse your test right now. Warning, it's quite counterintuitive. Run the test, and if the test is passing without your fix, well, you're still not understanding your fix, and you have to come back like before in previous steps. And if you launch your test and it breaks without your fix, well done. I think let's say it. We have a fix. We have a fix, Yann.
Yes. Finally, we got it. That wasn't easy. In fact, it wasn't easy enough. As engineers, we are lazy people. It's our job to make things simpler. During our debugging journey, we may have crafted some tools to speed up our process. If we added F-check pages, customized logs, more specific error messages, it would be a shame to keep them for ourselves. We should commit and share them with our team instead. For instance, on my current project, we have to make complex calculations to compute insurance refunds, involving something like 15 or 20 parameters. To have a better understanding of what's going on, we spend some time developing a small hidden table with the content of all these parameters. The first time we showed it to our client, his reaction was to say that we will use this table later for admin pages. So it wasn't a waste of time at all. Because according to a study from the Cambridge University, we, developers, spend 51% of our time debugging. That's huge, but not a complete surprise. We spend more time fixing some edge cases and asking ourselves what's wrong than typing the outline of our features. Therefore, by debugging faster, we spend more time actually developing, and thus the team will go faster. Okay, of course, it would be even better if the bug we just fixed never shows up again. That's what we will try to accomplish here. First, we need to think about how the bug was introduced in the first place. It may be because of a misconception, a difference between the way the application works in reality and its representation in the developer's head. This mistake may still exist, and we may still have duplicates or sidekicks of our bug in the codebase. Now is the time to track them and eradicate them.
And it's exactly what I did with one of my team. On a private cloud platform, we had a big React single page app connecting to multiple providers. Firewall API, user management, servers management, well, a cloud platform. But TypeScript was not a thing yet, and there was no centralized modelization in this legacy code. Hence, this famous error message: cannot read property name from undefined. Indeed, the domain data was never structured the same way. A change could lead to a bad side effects, and emptiness was not managed really well in the app. So we applied the first aid and used load-get, to have a default empty value in cases our objects were not properly formatted. And we did it in most of the code base, so the bug was then really more seldom thanks to this.
Okay, now time to think why someone hasn't seen the bug earlier. One reason is because there wasn't a test highlighting it. It's a good idea to have a test covering this bug. For example, an end-to-end test emulating what we're doing in step 10, for example, and add it in your CI. Another reason may be because the code is messy, unclear, badly designed. Dirty code acts as a nest for bugs. They can hide and prosper in it. It is not necessary to refactor after each bug, but we should consider it every time.
I also have an example on this. It was on the same private cloud app I spoke about earlier. A feature was a complex form with multiple steps and reused inputs. It was an interface to create firewall rules between servers, between networks actually. You choose the source network in the first step, the destination network in the second step, and the protocol ports and whitelisting rules in the third step. So firewall configuration. The first and second step were very similar and used the same subform component. It was really the same file. But to know if you were rendering a source or a destination form, the legacy code was using a Boolean called is source or destination, and the predicate was used everywhere in the component trees. The whole form was really a forest of if. We had 4 bugs per week, and debugging was an actual pain. 8 hours to find a missing exclamation mark. So we decided to refactor the whole interface with my teammate. We made a decorative finite state machine and used polymorphism with composition instead of an ugly Boolean. It took us 2 weeks, and we never had a bug again on this feature, of course. But what is already enjoyable is that 6 months later, a new developer had to improve the feature. He did it almost instantly, and said the code is amazing. Actually, I did not code. I just changed some configuration.
Okay, now the code is in a better shape. We have safety nets now, and we have the next step is to change the misconception I spoke about earlier in the heads of our team. That means to train them, share good practices with them, communicate what you just learned about the application with the bug.
And I seem to be the example guy today. I have another example on the technique. I was leading a team of 8 developers. Some of them were learning React.js. In my team, one experienced developer made a presentation of common React pitfalls, like not setting the key attributes on list elements. And the same day, one of the rookie fixed a bug with something she just learned. And she said out loud in the open space, hey, it's exactly like today's training. So train your people, seriously.
Another approach is to make sure that no one has to write code prone to have bugs. We can generate code following templates with tools such as plug.js, have pre-commit hook, linters. In a nutshell, automate the repetitive and manual tasks a developer has to make to work on the project. Now we're done. The bug has been removed and won't come back. Let's enjoy this victory against a notorious enemy in our work. That feels good, isn't it?
Take this bug!
Our last piece of advice today is to keep memory of the hardest bugs we encounter as stories. Because stories are fun. Stories are easy to follow, easy to remember, easy to share in a blog post or at afterworks. Stories can also be a way to remember weird hypotheses for the next times we will meet a hard bug.
Okay, one more thing before leaving you. If you learned something today and want to share it right now, Yann and I built an humble website with the 20 steps we just showed you. It's debug.guide, easy to remember. It's quite raw now, so we'll make it evolve. Of course, the design is quite very, very simple. And maybe someday we will publish some of your stories because we really want to make this website a collaborative effort. So reach us out on Twitter, etc. Maybe we can publish some stuff.
Yes. So that was all for us. Thanks for your attention. Remy and I hope you learned some stuff with this talk, or that it helps you put words on practices you gained through experience in the past. See you right now for the Q&A. Bye.
Gentlemen, what a brilliant talk. Thank you very much for doing that for HalfStack this year. I can see, Remy, you've done so much debugging that it's transformed you into a zombie, apparently.
Hard bug. Every time it's the same thing. I have to, come back from hell. So, from the grave.
I put on some Christmas lights to get in the Nightmare Before Christmas kind of vibe for your talk, so seemed fitting.
Some kind of gift.
Yeah.
So have you got any tales of when debugging's gone seriously wrong that you can tell us? What are the horror stories that you can share with us today?
Mine was something like 2 or 3 years ago. I was on a project and there was a background task running every day to check for every new domain name registered on Earth. It was something really big, really huge with loads of data. It was made before my arrival on the project, and it broke on one specific day. And we had to investigate after what happened this day. And after it was hard because we couldn't reproduce it after, because everything was fine the days after. And we took something like several days to understand that this day it went wrong because by downloading domain name file, the download was interrupted, and so the zip file was corrupted, and then everything was off rates. It was awful.
Sounds bad. Can you top that, Remy?
I have some stories that something that was not hard to debug technically, but to leave. I was working for a newspaper website the day there have been a terrorist attack in Paris. And so the website has been under a huge, very huge traffic. And it was like domino game. An Elasticsearch has been killed by the system, and everything then has gone down. And we had to repair everything step by step under huge pressure because the website was still up thanks to some caching, but it was like really a race against the time to leave of the pages. That's why the do not stress, I insist. It is specifically because of this story. I had some people just behind my back saying, "Oh, how are you remaining so cool?" and I say, well, if I'm not cool, I'm just gonna make more mistakes, and it's gonna be a mess to solve this problem. Well, it was really a hard time. It took like basically a full day of full work to really fix the issue and to make it safe for the next stories on the website.
That's nothing like that kind of pressure to put you under the stress of fixing debugging. I would have thought that you were just a cool guy in any situation, alone under that pressure.
Yeah, years ago, someone told me they worked like in the early days of Dojo. Like I don't even think we were 1.0 yet, and someone approaches me at a conference and says they work for like the U.S. Defense Department, and they just launched an app that uses Dojo to track all the missile silos somewhere, right? And I'm like, have you debugged this? Like what kind of testing are you doing? I'm like, I hope you don't have an event that allows you to fire missiles with Dojo, because that scares. So there's certain times where debugging can be really terrifying. Like trying to debug and oops, we launched a missile.
Yeah. No, we keep life safe with our job most of the time.
I heard a story in the past about Boeing engineers that had to debug something on the plane while it is flying.
Yes. Well, actually,
Wow.
yeah, that was really common, actually. So my grandfather, during World War II, he was the flight mechanic. So he was like they had like the pilot, the co-pilot, and the mechanic. And the mechanic was up there to fix things on the aircraft if they broke while they were flying it. Which is just, and then he worked for like Eastern Airlines in the same role for many years. He was the onboard engineer, like to troubleshoot and fix things. It's crazy.
Yeah, the cool stuff with plane operating system is that it reboots so fast. It is designed for this kind of issue that if something is crashing, it has to reboot like in less than 100 milliseconds. It's I'm not sure I would be able to develop some kind of stuff. But
It makes me wonder what kind of terminology you use when you work for an airline about bugs that crash, because you probably don't want to use the word crashing bug. I wonder what word you use instead. I don't know. Maybe if someone in the audience might know, but it's kind of scary. Yeah.
No.
Suggestions in the comment box, people.
Yeah, or you could just totally avoid this topic if it's uncomfortable. That's totally fine. So,
True.
Yeah.
There's obviously Halloween in the next couple of days. I believe you're both in France, and France has gone into lockdown.
Yeah.
Are you swimming in candy that you're going to be eating over the next couple of days, or are you sharing it around?
I think I'm gonna keep all the candy. No one's coming.
We won't need to give it to the kids, so
It's probably through the windows.
Oh, yeah. That's I was telling the story before we went live how my wife buys candy too early, and by the time Halloween arrives, we just have all the candy we don't want left to give out, like the stuff you get like the mixed bag of all the different varieties, and you end up with the stuff that you never want to touch, and the kids look at it like, where's the good stuff? Did you eat it already? And we're like, oh yeah, totally. This year in Phoenix, people are planning to just leave the candy by the street, like so you can stay far apart. And people are actually like creating little pathways, like with like people get really into it, like haunted houses and other stuff on our street, and so or our neighborhood, and but they're trying to make them like socially distanced, like putting markers down and stuff, which is kind of cute. But like any time I've ever been away on Halloween and we leave candy out, it just gets taken by like the first kid that comes along. So I don't know why kids are suddenly going to be honest because of COVID. So I assume all the candy will be gone within like 10 minutes this year, but who knows?
For candy, we could adapt.
Yeah, that is true. Yeah.
Worth adapting.
So how did you originally come up with the idea for this talk? Because I think you actually had the idea for this talk before you knew it was Halloween themed, which is really impressive. So
yeah, actually, I started with an internal article at our company because our CTO told me 7 steps to debug anything like 8 years ago. So from 7 steps, we came to 9 steps, then to 12 steps, then to 20 steps, because we decided the whole process thanks to a book called Debugging, I guess. And first of all, it was an article, the article which is the content of debug.guide. And then we decided to make a talk, and then we decided to adapt it for the Halloween context. So that's why we worked on readapting the content. But well,
we came in the title before. The act of debugging, when you are not really experienced, can seem like some kind of exorcism. And we try in this talk to give it a scientific approach. So we thought of Hercule Poirot, and so the contrast between the two was our title.
Nice. Yeah, I have this cruel habit of I receive proposals for talks, and I'm like, that's like 90% of what we want. Now, could you just give it this twist, like throw in a Halloween theme or make it about sci-fi instead of like whatever? And people are like, oh yeah, that would be fun. That would be cool. But it's just kind of like, we want to like have a little fun here and make sure the talks are really amazing and stuff. So I really appreciate you both making the time and rolling with it and having fun, putting on the zombie makeup and all of that and just having a good day with us. So any final thoughts before we move on to the next session? Or actually the next part is breaks. So we have a break, which is nice.
Well, we'll let you know if we update the debug.guide website. We really would like to put like the video of the talk and more stuff on it. So we'll let you know.
Okay, cool. Yeah, we'll share that with the community. And we do, like, obviously we're recording everything and we'll put stuff on YouTube later. We'll put stuff here in the hub for the next however much time. So cool.
Okay.
All right. Well, thank you so much. And we'll be back shortly. We obviously have stuff continuing as we go. So enjoy. Thanks.
Thank you, Dylan. Thank you, Tony.